Okay, we're going to finish up chapter 18. Chapter 18 talks about green chemistry. And if you're an environmental chemist, that's kind of what you're looking for, is ways to make things more green, more friendly to the environment. Okay, we know that the earth is basically a closed system. We can exchange energy, but remember, energy is not created or destroyed. We just keep changing its form, and sometimes it's not in a form that we can use. So we need to look at how to reuse what we've used before. Okay, so for our humanity to thrive, if we want to, stay on earth, live healthy and happy, we need to take care of her. So we need to keep the processes in balance. Okay, we have the earth's natural processes, but we've messed them up, so we got to put them back. Okay, so that's a lot of what green chemistry is. Okay, and again, a lot of environmental chemists work on stuff like that. You might be an environmental chemist that figures out a way to break down plastics, because let's face it, we have a lot of plastic and it never breaks down. When it first was discovered, it was like, this is great stuff, it'll never break down. And then we're like, yeah, it'll never break down. Now we got to figure out ways for it, to be recycled, to be reused. So there's all kinds of things that you can do if you're an environmental chemist. And again, green chemistry is the initiative to help design things or use application of chemical processes, products and stuff, to make sure that things are compatible with human health and to preserve the environment. So again, making sure that things can be recycled, make sure that things don't emit too many dangerous gases, make sure, like, they're looking at things to replace CFCs because they did a wonderful job, but they destroyed our ozone. So now we need to look at other things that won't harm the environment. Okay, so there's all kinds of things we can do, and you can see it all over. We have hybrid cars or electric cars. We're more energy efficient. There's all kinds of things we can do to help protect the environment. Okay, so the principles of green chemistry, first of all, is prevention. That's number one. Okay, it's better to prevent waste than to have to figure to clean it up. And we're notorious for creating a problem and then trying to fix it instead of stopping the problem before it even occurs. So that's the number one, priority, is let's not have a problem to fix. Let's prevent it before it even happens. We have what they call atom economy. Okay, it's methods to take and make chemical compounds that maximize, their job, so that when you're done, the starting atoms and your final product don't cause issues. And we want the maximum amount. We don't want to waste stuff, because if we waste stuff, it just goes in the atmosphere or in the ground or whatever. So we want to maximize and get everything we can out of our products. Okay, we want less hazardous chemical synthesis. Okay, at one point before we had the Clean Water Act and the Clean Air Act, they used to just dump their industrial waste in water, or they'd let it go up in the air until we had, you'll have to read about it sometimes, but there was a river in Michigan, in Battle Creek, Michigan, that actually started on fire. It was because there was so much industrial waste in it that the river was on fire. And how do you put out a river that's on fire? You can't add water to it because the water is burning because there's so much chemical waste in it. And things like that happen. You've got, organizations like Greenpeace and the Sierra Nevada Club, and you've got, a lot of organizations that finally said, you know what, we need to start taking care of the environment. That's where the Earth Day process came in. So, sorry, my dogs are squeaking. Anyway, so we need to make things less dangerous. We need to make sure they're not toxic, make sure they don't do anything bad to the environment. Okay, we need to design safer chemicals. Okay, there's a lot of cleaning products you can see that are safer in the environment, so they're not toxic. Okay, they still do what they're supposed to do, but they say usually they're more natural or things like that. But you want them to still do their job, but you just want to make sure they're not toxic to the environment. Again, safer solvents. The use of auxiliary substances should be eliminated whenever possible. Okay, we want non-toxic. There's some things, unfortunately, that we still use a lot of toxic substances, and then we just let them sit around, and then somehow they get into the environment. We're trying to avoid that, and industry can't do it. There's probably more bad waste coming from households, from people that are thinking, it's just me, I can dump this down the drain. as opposed to industries, because they get fines. Bad things happen to them, so they can't get away with that. But unfortunately, household waste is probably still our number one, because people just like, it's just me. Well, usually it's not just you. There's a lot of people that are doing that. Okay. We need to be more energy efficient. Okay. We have, and this is wonderful in the car industry. I mean, we have so many more efficient cars. They get way better gas mileage, which is awesome because then it saves you money. The nice thing about green chemical principles is usually they save money. Okay. Like recycling, you get money for it. Everything that you can do might take you a little bit more effort, but it does save money. Okay. So we have requirements for our cars for, here it says, we have design for energy efficiency. They have lots of green programs and stuff. You get tax credits for doing things like this. Again, carry out reactions at room temperature and pressure so that you're not using energy, you're not using heat, that kind of stuff. We need to use renewable feedstocks, okay, raw materials that can be recycled, renewable, whenever it's practical. Reduction is huge. I mean, again, recycle, you always hear recycle, reduce, reuse. But honestly, if we can reduce what we're using in the first place, not use as much, okay? So there's a lot of devastation that occurs because of packaging, the wonderful thing is they have changed that. Back in the day, again, when we rode dinosaurs, like all the fast food restaurants, they packed all their sandwiches in styrofoam. Styrofoam is not good for the environment, you guys. It's not. There's still cups that people get their coffee in, but now they wrap their sandwiches, in paper that is very recyclable. So there's been a lot of changes to minimize waste, okay? We have catalytic reagents that improve yields. Again, when I talked about your catalytic converter in your car, that converted, it basically has a catalyst. If you remember, catalysts aren't involved in a reaction, but they help things. They cause the waste in your car to add more oxygen to it. So instead of carbon monoxide, you get carbon dioxide, things that are, that aren't so dangerous, okay? We want to design things so that, when we're done with them, we can get rid of them and we don't have to worry about them causing problems in the environment. In other words, they'll break down. Once their function is over, they don't persist in the environment. Again, these are things that are biodegradable, things that'll break down or reuse. Now they use tennis shoes. They cut up the rubber and from tires and everything else, and they use them on the highways. I think they make tracks now out of used tennis shoes, the rubber part of tennis shoes. So again, using things that don't persist in the environment are things that can be reused. Okay, real-time analysis for pollution prevention. They look at things that help to avoid. They monitor the formation of hazardous substance. Hopefully nothing like what happened in London would ever happen again, because they'd be aware of it, well aware of it before it happened, so they could do things. There's all kinds of things. And again, you get green credits, so you can only put so much, in the air. If you do other things to reduce your carbon footprint, you get credits. There's all kinds of things like that are going on. We have safer chemistry for accident prevention. Okay, solvents have to be titrated. They have to be, you can't just dump an acid down the drain. You have to titrate it with a base and make sure that it's treated carefully. You can't just, like I said, you can't just dump that stuff down the drain. That's not safe. It's not good for the environment. Okay. So here's an example of a green chemical reaction. We're using toluene and methanol. Okay, these are two organic compounds. We put them together, we get styrene, like polystyrene. If we replace the chlorofluorohydrocarbon in there with supercritical, in other words, make this reaction happen at a colder temperature, then instead of using CFCs, we can still get our product, but we don't have to, use that chlorofluorohydrocarbon solvent anymore. And again, remember we talked about that. That's not good for the ozone. Okay. Actually, you can't. It's illegal. if you remember from the Montreal Protocol, they said, no more CFCs. The amazing thing about the Montreal Protocol, it was the first time that all the countries got together and say, this is all of our problem, not just yours or yours. Let's do something about it. And they agreed to do something about it. They're still working on global warming. There's been a lot of countries that have done some things, but there's still some that are a little iffy. So anyway, here's again an example of changing like the temperature, using supercritical CO2 instead of the CFCs, and you end up with your product, but now the process doesn't produce waste that we don't want to use. Okay, so that's green chemistry, and that's chapter 18. So if you ever want to work on environmental issues and really get down to the nitty-gritty of it, you'd probably be an environmental chemist. Okay, so that's it for this chapter.